you will learn to add, subtract, and multiply radical expressions. The procedure is very much like that for adding, subtracting, and multiplying polynomials. By noticing the similarity between the two procedures, you will be able to better remember both of them. So try to notice the similarity so that it will make it easier for you to remember how to add, subtract, and multiply radical expressions. Let's start by looking at an example from polynomials. Let's consider 7x squared y subtract 3x squared y. The terms are alike. They have the same literal part. Since they have the same literal part, the literal part is a common factor. So I could factor out the x squared y from both terms and be left with 7 minus 3 times x squared y. Now I can simply subtract to get 4x squared y. Now in order to do that problem, you do not go through all those steps. What you would do is simply subtract the coefficients and keep the literal part. You would say 7 minus 3 is 4. The answer then would be 4x squared y. In fact, I'm going to put on the screen the same rule that you had earlier. To combine like terms, one keeps the literal part and adds the numerical coefficients. So notice the literal part is x squared y. You just keep the literal part and you add or subtract the numerical coefficients. 7 plus a negative 3 is 4. The same procedure will work for radicals. But before going into radicals, before going into the adding and subtracting of radicals, we do need to consider like radicals. Like radicals have the same index and the same radicand. Like radicals have the same index and the same radicand. Let's look at some examples. What I want you to do is to look at the screen as I go through, and before I actually do it, try to determine which radicals are alike. So we want to circle the pairs that are alike. Let's look at the 8 times the square root of 2x and 7 times the square root of 2x. Well, like radicals have the same index and the same radicand. I'm not even looking at the coefficients. I'm only looking at the index and the radicand. Both of them have an index of 2. Both of them have a radicand of 2x. So therefore, these two radicals are alike. The next pair are different. Here we have the cube root of 2x. Here we have the square root of 2x. The index is 3. The index is 2. Since the two radicals do not have the same index, they are not alike. The third example. The two radicals have the same index. Both of them have an index of 3. Both of them have a radicand of x squared. Same index, same radicand. So therefore, the radicals are alike. Let's look at the last pair. The two radicals have the same index, but the two radicals do not have the same radicand. One has the radicand 3x, the other one has the radicand 2x. So they are not alike. One can combine like radicals. So you can combine like radicals. Let's look at 4 times the square root of 3x, subtract 8 times the square root of 3x. Now notice that the radicals are alike. They have the same index 2, the same radicand 3x. So in order to combine them, one simply keeps the radical part which is the square root of 3x, and 1 adds or subtracts the numerical coefficients. 4 subtract 8 is negative 4. So the answer would be a negative 4 times the square root of 3x. Let's see why. It's the same reason for polynomials. I have a common factor of a negative 3x. Since I have a common factor of negative 3x, I can factor out. See, I have a common factor of the square root of 3x. Since I have a common factor of the square root of 3x, I can factor out the square root of 3x. Factoring the square root of 3x from 4 times the square root of 3x leaves me with 4. And factoring the square root of 3x from a negative 8 times the square root of 3x leaves me with negative 8. Now I can combine 4 plus a negative 8 to get negative 4. So the distributive property is why I can combine like radicals. Let's remember how you do it. So I'm going to put a star and give you the rule to add or subtract radicals. The first thing you want to do is to reduce all terms. So to add or subtract radicals, the first thing you do is reduce all terms. Then the second thing, you combine like radicals. And note, one cannot combine unlike radicals. One cannot combine unlike radicals. Let's look at some examples. Let's simplify the square root of 18 minus 3 times the square root of 8. As they stand now, the radicals cannot be combined because they are not alike. Here your radicand is 18. Here your radicand is 8. The radicals are not alike, so they cannot be combined now. But what I can do, I can simplify both of them to see if I can convert them into like radicals. Now in order to simplify square root of 18, I need to break 18 into what is a perfect square and what is not. Well, 9 is a perfect square, so I can write 18 as the square root of 9 times the square root of 2. So the square root of 18 is the square root of 9 times the square root of 2. I can factor the square root of 8 into the square root of 4 times the square root of 2. 8 is the same as 4 times 2. Now remember that when I factor it, one of the factors must be a perfect power, the other is what's left. So 4 is a perfect power, 2 is what's left. 9 is the perfect power, 2 is what's left. Now I can take the square root of 9 to get 3, so I have 3 times the square root of 2, minus 3 times, I can take the square root of 4 to get 2, so I'd have 3 times 2 times the square root of 2, or I have 3 times the square root of 2 minus 6 times the square root of 2. Now the radicals are alike. They have the same index of 2, they have the same radicand of 2. So I simply keep the radical part, square root of 2, and subtract the numerical coefficients. 3 subtract 6 is negative 3. The answer is negative 3 times the square root of 2. Anytime I ask you to simplify radicals by adding or subtracting, the first thing you want to do is to simplify both of the terms, hoping that you'll end up with like radicals. If you do end up with like radicals, they can then be combined.